Our star, the sun, the sun. It's a magnificent celestial body that has fascinated humanity for millennia. From ancient civilizations worshipping it as a deity to modern science unraveling its mysteries, the sun has always been at the center of our existence. It's a blazing ball of light and heat. The sun's surface, known as the photosphere, reaches temperatures of about 5,500 degrees Celsius. But that's just the beginning. The core, where nuclear fusion occurs, is an astonishing 15 million degrees Celsius. This immense heat and light travel across space to reach us, providing the warmth and energy necessary for life. This giant star is the center of our solar system. It holds the planets, including Earth, in its gravitational embrace, ensuring they orbit in a stable manner. The sun's gravity is so strong that it governs the motion of everything in our solar system, from the largest planets to the smallest particles of dust. Without the sun, life on Earth wouldn't exist. Its energy drives the weather, ocean currents, and the water cycle. Plants use sunlight to perform photosynthesis, creating the oxygen we breathe and the food we eat. Every living organism on Earth, directly or indirectly, depends on the sun's energy. It provides the energy for everything we do, from the electricity that powers our homes to the warmth that allows us to enjoy outdoor activities. The sun's energy is harnessed in countless ways. Solar panels convert sunlight into electricity, offering a renewable and sustainable energy source that can help combat climate change. The sun is incredibly powerful. Solar flares and coronal mass ejections can release as much energy as billions of atomic bombs. These events can affect space weather, impacting satellites, communication systems, and even power grids on Earth. Understanding these phenomena is crucial for protecting our technology and infrastructure. It's hard to imagine its size and energy. The sun is about 109 times the diameter of Earth and could fit over 1 million Earths inside it. Its energy output is so vast that it could power our entire civilization for millions of years, yet it's just an average-sized star in the grand scheme of the universe. But understanding the sun helps us understand our place in the universe. By studying the sun, we learn about the processes that govern all stars, including those that might host other forms of life. The sun is a window into the workings of the cosmos, and its study continues to reveal the wonders of the universe. The sun's ingredients. The sun is mostly made of hydrogen and helium. These are the two lightest elements in the universe. The sun is like a giant ball of these gases. Gravity pulls everything towards the sun's center. This creates intense pressure and heat. These conditions are perfect for the sun's energy production. Fusion powerhouse. Deep inside the sun, something amazing happens. It's called nuclear fusion. In fusion, hydrogen atoms combine to form helium. This process releases enormous amounts of energy. It's this energy that powers the sun. Think of it like a giant continuous explosion. The energy from fusion travels from the sun's core to its surface. This journey takes a very long time. It can take thousands of years for the energy to reach us. The energy travels in the form of light and heat. We see this energy as sunshine. It's what warms our planet and makes life possible. Solar energy is essential for life on Earth. Plants use sunlight to make food through photosynthesis. This process provides oxygen and energy for other living things. The sun's energy also drives our weather patterns. It heats the Earth's surface, causing air and water to move. This creates wind, rain, and ocean currents. The sun is about 4.6 billion years old. This massive ball of burning gas has been the center of our solar system for eons, providing the necessary light and heat to sustain life on Earth. Over these billions of years, the sun has gone through various stages of its stellar evolution, each phase contributing to the dynamic environment of our solar system. It's about halfway through its life cycle. Currently, the sun is in what astronomers call the main sequence phase, where it has been for the majority of its life. During this period, the sun fuses hydrogen into helium in its core, producing the energy that we receive as sunlight. This process is incredibly stable. allowing the sun to shine consistently and brightly. Don't worry, it has billions of years left to shine. The sun is expected to remain in this stable phase for another 5 billion years or so. This means that for the foreseeable future, the sun will continue to be the reliable source of energy that it has always been, supporting life on Earth and driving the climate and weather patterns that we experience. Eventually, the sun will run out of hydrogen fuel. As it exhausts its hydrogen supply, the core will contract and heat up, causing the outer layers to expand. This marks the beginning of the end for the sun's main sequence phase. The changes in the sun's core will lead to significant transformations in its structure and behavior. When this happens, it will go through changes. The sun will start to fuse helium into heavier elements like carbon and oxygen. This process will cause the sun to swell and become more luminous, dramatically altering its appearance and the conditions in the solar system. The increased energy output will have profound effects on the planets, especially those closest to the sun. It will become a red giant star, much larger than it is now. In this red giant phase, the sun will expand to many times its current size, potentially engulfing the inner planets, including Earth. This transformation will be a spectacular yet destructive event, marking the final stages of the sun's life as a main sequence star. Eventually, the outer layers will be ejected, leaving behind a dense core known as a white dwarf, which will slowly cool and fade over billions of years. The sun is just one of billions of stars in our galaxy. It sits in a relatively quiet neighborhood of the Milky Way, a spiral galaxy that spans over 100,000 light-years across. Our sun, a G-type main sequence star, is located in one of the spiral arms, known as the Orion arm. This arm is a minor spiral arm, nestled between the larger Perseus and Sagittarius arms. The sun's position is about 27,000 light-years from the galactic center, where a supermassive black hole resides. This black hole, known as Sagittarius A*, is a staggering 4 million times the mass of our sun. The sun orbits this galactic center at an average speed of about 828,000 kilometers per hour, taking approximately 230 million years to complete one full orbit. This journey is known as a cosmic year or a galactic year, and our galaxy is just one of billions in the universe. The observable universe is estimated to contain over 2 trillion galaxies, each with its own unique structure and composition. These galaxies range from small dwarf galaxies with just a few billion stars to giant elliptical galaxies containing up to 100 trillion stars. The sheer number of galaxies and the vast distances between them are mind-boggling. For instance, the nearest galaxy to our Milky Way, the Andromeda galaxy, is about 2.537 million light-years away. Despite this immense distance, Andromeda is on a collision course with the Milky Way, and in about 4.5 billion years, the two galaxies will merge to form a new galaxy, often referred to as Milkomeda or Milkdromeda. The vastness of space is truly awe-inspiring. When we look up at the night sky, we are peering into a universe that is 13.8 billion years old. The light from distant stars and galaxies has traveled for millions or even billions of years to reach us. This means that when we observe the cosmos, we are looking back in time, witnessing the universe as it was long before the Earth even existed. The scale of the universe is almost beyond human comprehension. For example, the observable universe is about 93 billion light-years in diameter. This vast expanse is filled with countless stars, planets, nebulae, and other celestial objects, each contributing to the intricate tapestry of the cosmos. The sun reminds us of the incredible forces at work in the universe. It is a massive ball of hot plasma with a core temperature of about 15 million degrees Celsius. The sun generates energy through nuclear fusion, converting hydrogen into helium and releasing vast amounts of energy in the process. This energy radiates outward, providing the light and heat that sustain life on Earth. Solar flares and prominences are visible manifestations of the sun's dynamic nature. These eruptions can release as much energy as billions of atomic bombs and can have significant effects on space weather, impacting satellite communications and power grids on Earth. It's a source of wonder and a reminder of our connection to the cosmos. The sun's energy drives the Earth's climate and weather systems, supports photosynthesis in plants, and provides the warmth necessary for life. As we gaze at the sun, we are reminded of our place in the universe, orbiting a star that is just one of countless others. The sun's presence in our sky is a daily reminder of the vast and interconnected nature of the cosmos. It inspires us to explore, to understand, and to appreciate the incredible universe we are a part of.